Awesome. Thank you, Shannon. Sweet. So we're just going to let folks trickle in here for another minute or so. But for those of you who are joining, welcome to the Manufacturers Roundtable on cold climate heat pumps. We're super excited to have you here and talk about this technology. All right. Shannon, would you do the next slide, please? Yeah, so we have an awesome sponsor today for this webinar in the form of CETA, the California Energy Design Assistance Program. And we have Sean Williams on from CETA to talk about the program. And after that, we will get into our main portion of the webinar. Sean, I'll turn it over to you. And you can just say next slide when you want the next slide. Hey, Sean, I think you're on mute. That's all right. I'll just go ahead and discuss the CETA slides then. So yeah, the California Design Assistance Program is the only statewide incentive program for new construction and major retrofits. It promotes both electrification and decarbonization. CETA works in collaboration with project teams to reduce energy demand, consumption, and emissions. And it serves a variety of building types, from public to high-rise and even agricultural projects. So next slide. So why participate in CETA? There are several benefits here. Decarbonization analysis of your energy costs and paybacks. It is specifically tailored for one's own project goals. They also offer financial incentives to offset decarb costs. And lastly, demonstrating a commitment to high performance building practices and design. Next slide. And this is a little bit more information on the incentives themselves. So it's a $2,800 design team incentive per project. So kind of in addition to that analysis, there is a thank you for participating as well. Next slide. And a little bit about the high performance measures here. CETA is aiming to exceed California's decarbonization standards through these high performance measures, not only advancing the market, but also qualifying for enhanced incentives. And there is a link you can click on right there for eligible high performance measures. And yeah, that's it from CETA. And if you have a project you want to discuss, you can scan this QR code. You can also reach out to Sean Williams or Tina Hendricks at the emails listed there. Thanks for being on. And with that, we will go into the bulk of our webinar, which is on cold climate heat pumps. And cold climate heat pumps are a super exciting technology. There's been the unfortunate myth circulating for years that heat pumps don't work in cold climates. And today we have 4 different manufacturers on to talk about their products and why they very much do work in cold climates. There have been some awesome innovations like inverter technology in recent years that enabled heat pumps to succeed in just about every climate in the US. So whether you're in, Ohio or New York or, anywhere in cold climate regions 5 or 6, and even in 7 for many cases, you can stay perfectly warm throughout a cold winter season using this clean, decarbonized technology. And we're going to discuss what makes heat pumps succeed in cold climates. We'll also discuss some of the different product offerings, and there are a whole bunch of form factors available these days, as you'll see from our various manufacturers, from ducted units to mini splits to even wall hung units. So whatever type of home or building you're in, there's definitely a form factor that should work for that. And lastly, we'll also touch on performance at different temperatures. So this is a huge factor. Performance obviously is going to be the best when your delta, or the difference between the outdoor temperature and the desired indoor temperature, is minimal. But as we'll see, even at very low temperatures, sub-freezing, these heat pumps still perform very well and keep you toasty. And with that, next slide, please. I want to introduce today's panelists. So Sam Beeson is from LG's utility team. He is a senior business development manager working on heat pump focused electrification activities. James is a senior business development manager at LG. He is a seasoned professional with 4 decades of experience, and he joined LG's utilities team as a senior business development manager. Sam Lamos works at Gradient. She's a public policy manager who is passionate about environmental justice and energy equity. And lastly, we have Jonathan out of Daikin. Jonathan is a nationally regarded expert in residential contracting and the co-owner of the heat pump store. So we're really excited to have all 4 of you on the call today. Jonathan is up first, and Jonathan, I will turn it over to you for your slides. Thank you all for being here.
Well,
and a quick note, folks who are on the call, kindly put your questions in the Q&A box, not the chat on the bottom of the screen. That will help us stay organized. And for each of the presenters, after they are done, we'll save some space, a couple of minutes to go over any of your questions rather than saving them all for the end. So once again, please put your questions in Q&A.
all right. Well, Noah, can you see my slides?
I can indeed. Looks great.
All right, great. Well, thanks for having me. Today, I'm going to talk a little bit about Daikin and our thinking around cold climate heat pumps. And I think it's a challenging subject. I'm really excited to talk about it. And because, there's no generally accepted definition of what a cold climate or a cold climate heat pump is. And so I think to kind of ground this discussion, I thought I would show what's called a climate map from the IECC. And the general thinking around what is a cold climate in the US, if you look on the map, anything that's 5, 6, or 7 are considered cold climates. So that means there's the temperatures that get reached during the winter months and during heating season, and then the amount of time spent at particular temperatures determines where you would fall on this with regard to the heating season. However, in my practical experience selling these products and looking at the data a little bit more closely, there are parts of zones 3 and certainly parts of zone 4 where there's a lot of hours spent heating. And while those hours aren't as cold as 5, 6, and certainly not 7, they homeowners typically do decide to invest in a heat pump in those areas that's purpose built for heating. And so in my working definition, a cold climate heat pump is a heat pump that is purpose built for heating. And so that's the working definition I'm going to sort of speak to today. And in my experience, there is a lot of misinformation or some perhaps old thinking that exists by contractors and homeowners alike that heat pumps don't work in cold climates. And I'm hoping today that all of us can help dispel that myth, because today's modern heat pumps are very different than the earlier generations of heat pumps. And they work great when they are sold properly, when that sale includes, setting the right expectations, teaching the homeowner how to use the heat pump, designing the installation to meet the particular needs of the home and the homeowner, how these heat pumps are installed and set up to operate. It makes a huge difference on how well they perform and how comfortable they make homeowners. And then finally, literally in the first year or 2 of the operation of that, if a homeowner has never lived with a heat pump, it can be very challenging to support that homeowner for contractors who are new at doing this business. None of this is rocket science, so thankfully it's all very learnable skills, but I think it takes an identification that this is a different beast, and it's a different when you live with a heat pump to heat in your home year round. So today, heat pumps are not sold everywhere every day. And that's because there's some perceptions that older generations of heat pumps, didn't work as well. And so that people haven't updated their thinking about what these new heat pumps can do. And so I thought I'd just begin by saying, a modern heat pump is completely different than earlier generations. It's a sophisticated computer controlled machine with lots of really interesting technologies involved. A computer program that's highly sophisticated includes things like machine learning and particular algorithms that learn over time, control a compressor that can vary its rate of operation. And then additionally, the fans that move air inside can vary their operation independently. And then the electronic expansion valve is a fancy way of saying the metering device or the flow controller for the refrigerant that is the heart of the system can change the pressures and then the flow rates of a refrigerant. And through all those different controls, we can manipulate these very small, very quiet, very technologically advanced machines to do great things and produce heat, lots of heat at temperatures that we're just not able to do with earlier technologies. So thanks to all of these wonderful technologies, it's very typical now to have heat pumps that do 100% of their rated capacity, even at 5 degrees. And you're going to see today from some of the other manufacturers that envelope's being pushed further. And then these machines can continue to operate well down below -13, which is frankly, a very cold temperature. Um, there are very few places where people live in any quantity in the US where we design for that low of a temperature. So, yeah. So as you think about heating with heat pumps, I think it's useful to think about this sort of trend that you'll see on this graph. And as you move to the right, you increase in sort of technological sophistication. And as you climb up on the graph, you increase in an ability to produce comfort and energy savings. And so, there's no one type of heat pump. It's not like like an automobile. There's many different kinds. There's pickup trucks, there's sport utility vehicles, and they all have their different uses. Sedans, buses, trucks, right? You get the gist of it. And heat pumps are no different. We have basic heat pumps which can work in conjunction with a furnace. And it's possible this technology is mature. It's been around and successfully applied starting, I think, in the early 2000s. The technology really got good. However, the stuff that I'm interested in, I think we're all talking about today, are more the middle and upper technologies. They have this high-tech variable capacity or computer controlled ability as foundational to their technology. However, the one technology that I'm really passionate about, which I think kind of meets the decarbonization needs most successfully in cold climates, are these zonal variable capacity heat pumps that use very little ductwork, if at all, and which, when applied properly, can require no backup heat to operate. Every home's a little different, but that's the general theme. I feel very comfortable saying your home might need some modifications to be able to operate that. But we have friends in the industry who live in homes in climate zone 7 that successfully heat their home all year winter long with the technology on the upper right. And it's this ability to use several small, highly efficient heat pumps placed strategically throughout the home that's zonal, that is able to achieve that. So in looking at these three types of heat pump, I won't go into this in great depth because there's a lot of information here. but dual fuel heat pumps could be the entry level place for most homeowners. However, if you want to decarbonize, you have a choice between the middle option. It may need electric backup heaters for the coldest days. And in my opinion, those should be minimized and are least desirable. And so the zonal variable capacity, to me, is the state of the art. And so just to give you a quick run through of the two, that middle and right type, Daikin's been making this product called Sky Air ducted systems. We have two types of ducted machines that go inside that you see on this picture. They're rated for 100% of the rated capacity at 5, and then can go, depending on the model, do even more heat than that. Again, purpose of the built, designed to produce lots and lots of heat down at very cold temperatures. They have the ability to vary the temperature of the refrigerant. So on a mild day, you're not over conditioning the house. So they have all this slick technology that is designed to make incredible comfort and energy efficiency. And I just wanted to point out, like, the middle model, this FTQ30, the graph is saying that even though it's sort of designed around 30,000 BTUs of heating capacity, it actually, even at 5 degrees, can produce 44,000 BTUs of heat. So, like, this single model would provide most homes in America with plenty of heat down at the coldest temperatures. And if you need more for some reason, you have a bigger house or an older house, you just add a second heat pump. And it's just that simple. One for upstairs, one for downstairs, something like that. So, I mean, these things are super powerhouses, very efficient, and able to do amazing things that even just 10 years ago we didn't think were possible. We also sell product under the trade name Aurora, and this is a brand name that we've given to our cold climate heat pumps. This product basically, like I said before, offers 100% of the rated heating capacity at 5 degrees. It's got features like little special drain pans and all kinds of little gizmos that make it purpose built for the challenging cold heating climates. And then you can see there's all these different indoor types of units. This is how you do the zonal heating around your house. You have multiple heating appliances conditioning the various areas of the house. And just to give you some idea of the performance, we have multi-zone outdoor units where you can hook a couple of indoor units to a single outdoor heat pump. And these machines at 5 degrees make a lot of heat, 20,000 BTUs, 21,000, 36,000. And it's really just a matter of working with a contractor to get enough heat into the structure and then putting it in the right places within the structure. And after that, that's it. You just keep it clean, keep the snow from building up around the outside, set the temperature for what you find is comfortable, and leave it there. So, we're just giving an overview today, so I'll leave it there for now. But I just wanted to encourage you, if you're working on programs or working on, trying to increase adoption of heat pumps, there's 4 steps to success that I've seen, and that involves working with contractors mainly, or industry people, to help ensure that they have the right sales strategy that helps the contractor succeed at to educate the homeowner at their, let's say, kitchen table. And selling these products is a little bit different language and skills involved. It's easy to sell somebody a replacement furnace. They've had a furnace. It's worked for years. They're comfortable with that technology. But when you're offering someone something that they've never lived with, that they don't have experience owning and operating, you have to overcome that natural objection that comes with offering a new technology. And so the sales strategies are a big skill to teach people who haven't, who aren't there yet today. Okay, sales strategies is just the first step. After that, these are different machines. They work differently and their application is a little bit different. Again, not rocket science. It can be taught, it can be learned, but you want the contractor ultimately to have a home run, to be able to make a happy customer who's much more comfortable. They should be more comfortable in their home after a modern heat pump gets installed. That's the expectation we have as a manufacturer. And so, we also think the contractor should be able to have the same business success that they have selling furnaces and central air conditioners today. And so, part of that is making sure you design and apply the product in a way that can then make it installed in the same labor efficiency. And then finally, it's not good enough just to install this stuff and say, see ya, homeowner, you're on your own. We must, as programs and contractors and even brands, help people adapt to living with a heat pump. And that's why this is one of my little, missions in life, if you will, is to help contractors teach their customers how to live with a heat pump when they have never had one before. And and this is hugely important because we've seen this with utility programs around the country where heat pumps should provide a great energy savings benefit, but if the homeowner isn't taught how to use them in the right way, they don't save as much energy as they could. And so we want that energy to be available for everyone. And so I think we all have a vested interest in that. So, I have all this amazing content that I probably should say is available to you. It's on YouTube under the Heat Pump Nation brand. All the stuff I talk about in terms of after sales support, training, application is all there. So my email's up on the screen. And if I can be of any additional service or help to you, please feel free to reach out. That's it for me.
Jonathan, that was awesome. Thank you so much. And we have time for just one or two questions here. There were 21 questions, so a ton of interest during this. Awesome job. Thanks for all the engagement, people, and very appreciate you putting it in the Q&A too. Um, so one question was, are these cold climate heat pumps able to provide efficient cooling in the summer too? So, how efficient is that cooling? Are people really getting the best of both worlds here?
Yeah, the cooling's easy for these systems. It's kind of amazing. I have cold climate heat pumps in my house, and on a day in the 20s, they're working hard. You can see that the fans and the machines are running, but I have a videos when we got up to 115 a few summers ago, and the machines are just outside chilling. They're
Yeah.
barely working. So they excel at the extremes is a little bit of a way to say it. We call them cold climate because frankly, there's more marketing benefit to calling them cold climate, but most of the brands I know also excel at the extreme heat too. I mean, we certainly designed for that. I think my competitors on the call here, I think their products are more similar, frankly, than not. So I think they could speak to that too. Anything else before I sign off?
Yeah, so there are a whole bunch of questions. If you don't mind, Jonathan, just typing some answers away in the Q&A,
Sure.
I'm sure folks would appreciate it. And maybe a 10-second answer here. How long do these systems last before they break? I know it's a big investment, so.
Yeah, I mean, it's interesting. The more modern stuff tends to have a longer useful life than the others. Manufacturers don't like to claim a designed useful life, so I shouldn't really say. But in my experience, if the average useful life of an air conditioner is 8 years, I would feel pretty comfortable with a cool climate model lasting 10 to 15 years easily. And then with proper cleaning and care, like so regular maintenance, just to make sure everything's working right, I don't think it's impossible to get 20 years out of these. It really does depend on the care and the maintenance.
Awesome. Yeah, that's a great answer. Well, thank you again, Jonathan. That was great. I'm going to turn it over to Sam Beeson here from LG.
All right, I'll get my slides teed up here. Those come up all right, Noah?
Looks good to me. So I can still see your side view. So yep, now you're in full screen. Perfect.
All right. Yeah, okay, Sam Beeson here with LG. Um, our product line that I'll walk through today is what we call LG Red, just kind of builds on what Jonathan's talked about. He brought up some great information about the technology itself and the importance of proper installation. I'll cover some of those things. LG Red, I was curious. I recently joined LG. But I've been in the industry my whole life, but I was wondering what LG Red actually stood for. It actually stands for reliable to extreme degrees. So it's our product that, like Jonathan said, is kind of built from the ground up to operate in cold climates. LG is really proud to be a company that offers, we're very pro electrification, and we offer a product line that helps electrify homes across the US. Everything from kitchen appliances, laundry appliances, to our heat pump water heater, and then of course our HVAC products, both residential and commercial products that are variable capacity heat pumps, all the way to EV charging. Just kind of again building on what Jonathan talked about, this is just a snapshot of what those multi-zone systems that he talked about look like, where you've got an outdoor unit and then a variety of different indoor unit types that can be connected to this. It could be a wall mount or ceiling cassette. We've got concealed ducted units that are mid to high static, so can be used in short to medium duct lengths to really pick up sections of a home or a small business. And then floor consoles. We've got an art gallery unit. So there's just a really kind of what you had spoke of earlier, of form factors that can be applicable in people's homes. Just kind of diving into the cold climate piece, Jonathan talked about, as an industry, we've kept pushing the boundaries both on the low ambient and the high ambient side of things. LG was selected this year as the 2025 AHR Expo Innovations Award winner for a product that we've been working on with the University of Alaska, Anchorage, and Fairbanks, doing research kind of in a partnership with them. We continue to push those levels forward, and I wanted to walk through maybe the next few slides just showing what the capacity of heat pumps looks like. And I've got these labeled as LG, but as Jonathan mentioned, this would be fairly typical for variable capacity heat pumps in our industry. So this is a look at what we would call a standard heat pump, where you can see we've got temperature across the bottom and capacity up the left-hand side of the chart. So you can see this unit performs at 100% down to about 30 degrees. And then when we hit that ambient, it starts to lose capacity. But it still functions and operates pretty well down to -13, but it would leave a big gap if that piece of equipment was not properly applied to a residential or business building. So you could look at technology that exceeds that capacity. This would be what we've traditionally called our LG Red units that operate, again, at 100% down to 5 degrees and still have a pretty robust capacity down to -13, operating up there in the 70, 75, 78% capacity range, even at -13. This unit that I had just flashed up a second ago that we're working on in Alaska is going to be a product that we will start making commercially available in early 2025. It's what we call our LG Red Core unit. This unit produces 100% of its rated capacity down to -13 and 70% of its rated capacity at -31 degrees. So again, this is technology, like Jonathan mentioned, where these advancements have been taking place over a long time. No, you had talked about the myths that have been out there. I mean, heat pumps justifiably have a poor reputation of operating in cold climates or when it gets cold in the winter. Going back over the last 4 decades, there's a lot of that out there. So people have had bad experiences, but I think like we've seen advancements in other technology, heat pumps have come along with that. And so there really is good performance out there that can meet pretty much the demands of anywhere in any of the climate zones that we've talked about today. I wanted to create this chart It may look a little complicated when you first look at it, but if you look at the red line and the dark gray line, those are heat pump capacities similar to what we've just talked about. And then the yellow or golden line is the load requirements. And you can see as the ambient temperature drops, as we move to the left on that chart, the load requirement goes up. And traditionally what's happened when a heat pump reaches that crossover point, and maybe I can get my pointer up here and just show you this, might be a little easier. So when we hit this point right here on this chart, this is where the unit begins to not be able to meet the heating demand requirements of the space it's been designed for. So that gap has to be filled by what traditionally has been backup heat. We're trying to get away from that term. Backup heat is a bad idea for most cold climate heat pumps. You don't really need backup heat. Backup is implying that there's a big chunk of the load that's not going to be met by the heat pump. You can see this heat pump continues to perform down to lower temperatures, but it's not meeting the requirement. So you could select another unit that performs better. But as you get down into this minus 10 degree range, which, you know, in most of the climate zones we have around here, we don't get to those temperatures for long periods of time. I've got a friend that lives in Portland, Maine, that's been operating his house with 2 ductless heat pumps, cold climate rated heat pumps for the last 3 winters. He has no backup heat at all, and it gets pretty cold in Maine. But you can see where this line crosses in comparison to this other unit. This is what we would call supplemental heat, where there may be a few hours during the early morning hours where that load may not be met. And it could be met with just a little bit of heat. So the backup heat in this first example would be like 18 kilowatts to meet the load. 18 kilowatts, that's like a 75 or 78 amp load on a panel. You're just not going to be able to do that. Where this supplemental load of 3 kilowatts is about 12 and a half amps. So it's just going to come on to make up that little piece of difference. It's not like the heat pump isn't performing any longer. So again, we want to look at proper design for systems that go in. So I've created just kind of a little list that kind of, I think, goes right along with what Jonathan kind of concluded with, where if we want good outcomes for heat pump design and application, there's a few things you could do. One of the basic things that every project should have, whether it's a renovation, whether it's a retrofit, whether it's a new home, there should be a building load calculation for proper heat pump sizing that includes a manual J at the least, which is the load calculation for heating and cooling. And then a manual D would help with the ducting design and layout, how many CFM is going to be delivered to each space. And then finally, a manual S for equipment selection. There's great tools out there. There's tools that are used by professionals. I live in an all-electric home that was designed and engineered by a group out of Atlanta that we've done a lot of work with over the years. And so I had a room by room heat loss calculation. So I knew exactly what needed to happen. And so we used that building my home. I will admit that I had to argue a little bit with contractors as we put this system in because they didn't really like the design that I had done by this company. But anyway, we put it in like it was designed. I've been in it 2.5 years. It works fantastic. We were down well below design conditions in the Seattle market last winter for nearly 3 or 4 days. And my home was perfectly comfortable and my system was just purring along just fine. So again, load calculations being a big component of a good outcome of a application and design for a home. And then a quality installation, we can sell you the best performing, the highest rated, the highest SEER, highest HSPF unit out there. But if it's not got a quality installation, it's not going to perform to what it's rated at and what it's been tested at. We're in a period of time where equipment has never been more scrutinized. We've gone through moving from the HSPF to HSPF2, so from the M calculations to the M2, M1 calculations. Then we did testing for EPA to 5 degrees. We're now testing with new refrigerants that will go into the market starting this January 2025. So people should know going into this that equipment has really been scrutinized over the last few years with testing to the regulatory requirements. So again, the quality installation would begin with proper, the load calculation and proper equipment selection. And then equipment location, you know, you don't want that piece of equipment out there where it's going to get piled up with snow and buried and you won't even be able to find it in the winter. It's not going to operate very well like that. So again, equipment location, following the manufacturer's recommendations for piping. Piping lengths used typically if the indoor unit is over 25 feet from the outdoor unit. And again, each manufacturer may be a little bit different, but it would come pre-charged with enough refrigerant to meet that requirement if it was 25 feet or under. If it's over that, there's gonna have to be a few ounces, and they've got charts that tell people exactly how much refrigerant needs to go in to balance that load out. Then they get a charge verification to make sure that everything is the way it's supposed to be. Startup and commissioning is essential. Our home operates, matter of fact, everywhere we go now, my wife knows very little about HVAC, even though she's been married to a guy that's been in the industry his whole life. But now that we've lived in a home with a variable capacity heat pump, she complains about every home that we go stay at or every hotel that we stay at. They're drafty, they're noisy, they aren't consistent in their temperature. And so again, you can install this equipment with confidence that it will operate and you will have happy customers. And then finally, I think a really important piece of success is educating the homeowners, because this equipment operates differently than a forced air furnace, whether it's gas or electric. This equipment soft starts. It operates usually in a part load capacity. The indoor fans aren't, they're always operating typically, but they're not operating at full speed. So you don't hear it very much and you don't feel the drafts, and the temperature is just very consistent. So it's very unlike most of the homes across America. So again, I think there's just some things that we can work with on homeowner education to have a good outcome. That's really all I had to bring to the table today. I think as we go along, we'll hear other great insights from James and Sam.
Sam, that was awesome. Thanks so much. Really
Yeah.
loved that temperature capacity graph, especially. That's really nice to see. So just one thing here quick. A lot of people were asking about COP data. So I know it's the typical is just giving, HSPF or HSPF2 ratings. But yeah, I guess asking if manufacturers also provide COP ratings at different temperatures.
Yeah, we do. We have, so I think NEAP is a great resource. It's used by a lot of the programs across the country for cold climate equipment selection and performance. And so you can see those COPs at different temperatures. AHRI requires testing at 4717, and now the DOE is requiring 5-degree testing. So there's a lot of great information, and I think whether it's LG or other manufacturers, almost all that information is available on our websites, in our engineering manuals, or in our submittal data.
Wonderful. Well, thanks again, and sorry to rush, but we're going to turn it over to James.
You
Thanks
bet.
again for your presentation, and if you don't mind answering some questions in the chat too, that would be great. All right, James, I can see your screen, and now it's full. Perfect. Looks good.
All right, there we go. Thank you. Yeah, definitely like to introduce myself, James Marperus. I think Sam and Jonathan really did a great job at outlining cold climate equipment and all of the benefits in the industry and how we really need to start looking at that moving forward. But as well as cold climate equipment, there's also a lot of other changes happening in the industry right now at the same time with the adoption of said cold climate. And one of that is the new adoption of the refrigerants. And in this case, it's Puron Advanced for Carrier, where Carrier has adopted R454B for a large portion of our residential products. So in my presentation, I'm going to go over some of what is new coming over in the industry being produced by us. And that equipment, one of the big focuses of it was cold climate and making sure that it's able to qualify for a lot of the incentives that are out there right now that are geared towards cold climate. So moving on, we're going to cover a few things that are changing, and I think things that for sure should be noted when we're talking about new refrigerant. And just taking a look here at the new lineup, which is expected really now, fall 2024, we're going to start rolling that out. But one of the key points I want to highlight with the new refrigerant, in our case, Puron Advanced, is the new hardware that's associated with it, such as our A2L dissipation sensors, which should be expected with the new rollout of our equipment. And that's something that's really critical right now, because as we talk about the new refrigerant, we're looking at something which is, to be quite frankly, mildly flammable. But if we're looking at it on a flammability scale, it is right there on, okay, just this refrigerant can now actually ignite. The one below that is just completely not flammable. So it's something where we needed to put some new safety precautions in, and you could be expecting this with building codes and just with new installations. This is something that people are going to want to know for safety purposes. So not only that, those A2L sensors that will be in place in the new units to make sure that in the event that a leak does occur, we have some safety mitigations for that. But you can see here, we're also going to have some new service ports, which will be designated by that red cap for R454B, and also some new hang tags for the new refrigerant and all the proper safety markings, etc., on the packaging. Now, taking a look here, you can see we have that leak sensor on the indoor unit. And in the event that a leak were to occur, the fan would continue to blow in the unit to help dissipate whatever leak is there. We have shut-off valves to stop any refrigerant from coming into the space. And then the fan, in theory, will keep going in order to dilute that space and make sure that that refrigerant doesn't concentrate within a small area. Not only that, with the new equipment rollout, we have some upgrades and some system optimizations. And because of that, we're going to see as it applies to our efficiency levels, we actually have a very competitive product for that after switching over to the new refrigerant. I know there was some concerns with performances on once that occurs, but we're actually faring out very well there. And we're expecting that this product will qualify for a lot of those rebates, especially as it concerns cold climate, because of some of those optimizations. Just going into nomenclature, we're going to have some changes in the nomenclature designated by the numbers. In this case, 37 would be the outdoor units numbers that it'll start with, designating the new refrigerant. And on the indoor units, you'll start to see 45, designating that new refrigerant with our nomenclature. As typical, we have the regular lineup. And you can see from most manufacturers, it's very similar. But the way Carrier breaks it down, we have our Infinity tier, our Performance, and our Comfort tier. So that you could think of that as good, better, best. And in various sizes, and some new sizes that we're going to have rolling out. And then looking here at some of our single zone equipment, especially on the Infinity side, this is where you can see some of those performances with cooling up to 122F, heating down to -22F. On the indoor units, you're going to see that we'll be fitted with that refrigerant detection sensor. We have sizes going down to 6K now, and where we're able to experience 100% heating capacity at 0 degrees. So it's getting more and more competitive as time goes on between all the manufacturers right now. With the Infinity being our highest tier when it comes to our single zone equipment, you can see a lot of those high metrics in our EER2, also our HSPF2 and our SEER2, making it just an overall competitive product. Even in our comfort and our value tiers, you can see we have very competitive heating down to 5F, which I think right now is relatively standard with most manufacturers. But we'll continue going forward with that, especially with that new refrigerant being put in place. And then here we have our new fitted indoor unit, which can also be tied to our Infinity tier outdoor and our Performance tier outdoor. So we have one indoor unit that can be tied in with the different tiers of the outdoor. So that's giving more flexibility. I think that's something that's appreciated out in the field, especially when it comes to sizing and performance. The more flexibility, the easier it is for the guys on the field to sell and be more competitive. Likewise, we have our multi-zone systems coming out, and I think we've seen large improvements in our multi-zone, especially with this new refrigerant rollout. as mentioned, heating down to -22 in our multi-zone. We added new ports, one more connection port onto our multi-zone units. And likewise, these will be fitted with some of those safety shutoffs. Next, just going into some of the controls, we've consolidated some of those controls, just making it a lot easier and a bit less confusing. You can imagine with all the different remotes, we're starting to consolidate on the control side and also improving where we can on connectivity and connected devices, et cetera, making everything talk. So next, I want to roll into what we call our next generation of our crossover products. And I think right now, this one is really receiving a lot of highlights, especially in colder climates, because in this scenario, we're able to tie in our horizontal discharge outdoor unit, but then we can also pair that in to our fully connected indoor or air handler unit as typical. But then with this configuration, we can also do a crossover where you can do dual fuel, and you can tie that now horizontal discharge outdoor unit to your typical gas furnace air handler combination. With that, it's giving a lot more flexibility in installations, add-on replacements, and giving that option to do what typically I think is a hard decision to make in certain cases in colder climates of whether or not you want to go full electric or if you want to do dual fuel. But this gives you the flexibility to be able to choose. So right here, we can see that crossover outdoor with a fully electric, fully communicating indoor. You tie in with your auxiliary heat, but then you can also do the combination of your furnace with your evaporator coil, as you can see here, and your control interface and do a whole different type of setup. And with that, you can tie that in with your conventional refrigerant lines, insulation on your suction line only in this case. You can pair that in this, and I think this is something extremely competitive, at least for us, is our 24-volt interface, where you can tie that into any thermostat is built into the unit rather than a separate control you need to purchase. So if we're looking at that lineup and some of the performances here, we can do up to 100% heating at 5F. If we're looking on the performance side tier of the equipment. And we can go heating down to -22. And then on a comfort series, heating down to -13. And this will be considered our best, better, and our good combinations. And then here, looking at the next tier, where you see our SEER2, EER2, HSPF2, extremely competitive. As we're looking at the EER2, I know we're always talking about cold climate, but it's always in the advantage of the equipment. Better the EER2, the more rebates it will most likely qualify for. That's just the reality in order for it to qualify for the whole gambit of everything. But this we would also consider this to be definitely cold climate, very competitive specifications. I wish I had the COP data here. As you said, we mentioned to just highlight the SEER2, the EER2, and HSPF2, but NEEP is a good website in order to get that COP data and also the maintenance capacity data on here.
And James, I'm just going to give you a 2-minute warning here.
Oh, almost done.
Thanks.
Perfect. Last, one of the things I do want to mention is just the modular design of the crossover air handler, where you can see here we can do both a horizontal and a vertical type of configuration. It's fully modular and screwless connections where you can configure where you would want that blower motor and the coil, giving it full flexibility. Here in the bottom right, you could see that vertical setup and the horizontal setup. And we also added in dip switches where you can switch between the different sizes. So in this case, it's making it a lot easier when it comes to SKUs. where it can easily just be switched between an 18K and a 24K, or you could do a 30, 36, or 48 and 60. Same chassis, and the only thing to switch that is a dip switch. And then this can fit in your common areas where a typical gas furnace will fit in. And you can see that multi-position. So most of all these products that I mentioned here are definitely within the cold climate range. We're going to be able to hit those performance numbers needed in order to get different rebates, etc., and to give you the most flexibility when you're out there in the field trying to install the equipment. So this is something to keep a look at. We're continuously improving the equipment. And from what we see here, this should be expected in warehouses coming to you soon. And that's everything. Thank you.
Thanks, James. Really appreciate the exhaustive list of all the products there. Super, super cool to get a feel for everything. And it seems like y'all are doing some awesome research. So quick question here. There are a ton that came in again. So I guess we haven't spoken too much on upgrades, like home upgrades or amperage. How many amps is it typically required? I know there are a ton of different products, so it's probably hard to give an answer, but maybe range of amperage requirements, and are folks having to do home upgrades a lot when converting to heat pumps?
So is that directed to me or just in general?
Oh, that was directed to you. So sorry,
Okay.
that was a kind of in your experience from Carrier's product range. Is there a range of different amperage products that can help people avoid kind of home amperage upgrades, or is that just kind of part of the equation?
Yeah, that I would say that's a part of the equation, mainly to put that on to the contractor installing it to see what's appropriate in that case. If you need to do a full home upgrade in your electrical system or not.
Awesome. Awesome. And one more quick question too. You talked a lot about the refrigeration transition and the low GWP refrigerants Carrier is using. Do you see a difference in performance from switching over, in recent years to those lower emissions refrigerants?
I think that's a great question. So right now, it has been a big fight between all the manufacturers trying to squeeze out the best performance when we're switching over to that lower GWP refrigerant. So it's not a like for like, apples to apple change. From what I've seen is some cases we do have better performance across the board, and most of our line from what I've been seeing right now. That I don't think that can be said for everybody in the industry, and there's various reasons why. In our cases, we made some system optimizations in order to try to achieve better performance than what we had before. So we really had to go into and design the system, redesign, etc. But it's tough right now. There's only so much you can squeeze out of the system. And most of it is within the algorithm. As mentioned, it's a fully intelligent system. Most of it is behind the background on how we're pumping out the best BTUs possible. But I would say in general Carrier, we have slight improvements with the switch to the lower GWP.
Very cool to know. Awesome. Yeah, good for people to know that you don't have that trade-off, right? You can be both perform well, maybe even a little better, and be better for the climate as well. Thanks again, James. Really appreciate it.
Thank you.
And Sam, last but certainly not least, and you can feel free to go a few minutes over. Sorry for squeezing you on time at the end here. If people don't mind staying on for 5 minutes extra.
Yeah, no worries. Let me get my screen shared here and we'll get running. Okay, here we go, everyone. We're all good. You can hear me?
Screen looks great.
Okay, hi everybody. My name is Sam Lamas. I'm the public policy manager for Gradient. We are a startup based in San Francisco, California, and we manufacture a window heat pump, or otherwise known as a room heat pump, that is cold climate capable. So that's why I'm here also today. So a little bit of a different form factor from the other manufacturers that you've seen here today, that we will get into right now. Okay, so Gradient at a glance, basically our mission is to remove the installation barriers to installing high efficiency heat pumps to a variety of different types of housing. Specifically, our focus has been on high-rise multifamily, which has been a pretty tough portion of the housing market to electrify. We pioneered this product in 2022 with our first generation unit, which was moderate climate system, with our new cold climate system being released actually this month. We've partnered with NYSERDA, NYCHA, the CEC, and the DOE all to kind of drive forward this new product category of a window or room heat pump as a primary source of heating and cooling. And most recently, we received the CEE Integrated Home Competition Award, which was really cool. So, like I said, this form factor is slightly different from the other cold climate heat pumps that you've seen. Let me just hide that. So comparatively, right, a gradient system sits over the sill of your existing hole of your building envelope, which is your window. So this system goes through the window, wraps around the sill, and then closes with a bit of air sealing. So it's a super simple, straightforward installation. There's no drilling into the wall. There's no disturbance of the building envelope. And it's a zonal system similar to a ductless mini split where you would have likely one head per bedroom and then one in the common area. So just a super quick video here that gives a good visual around how this system is installed. It's installable by 2 lay people. Like I said, we put in an installation bracket that goes in first that's fitted to the windowsill. Honestly, this takes about the most time of the install. This system is then shifted into this L Tetris shape, like I like to call it. The external portion of the unit is then lifted up. Again, 2 people, it's about 140 pounds. It goes onto the bracket, maneuvers down. You put on that air sealing, that top bit of plastic, close the window, and you're good to go. This plugs into a 120 volt outlet, which makes it really ideal for, oops, I'm so sorry, simpler installations. Let's see. Okay. There we go. So we anticipate that this product can fit into about 50% of US residential windows. You can see this schematic here shows the type of window width and depth that the unit can be installed into. So at least 26 inches and a minimum of 10 inches up to 18 inches. And I think that can be stretched to 20 according to our most recent projects that we've been working on. But it's quite a bit of a sill depth if you've ever looked at your sill depth. A couple of specs here, just to go into the technical bits. You can see the dimensions here on the top left. Like I said, it's about a 140-pound unit. It operates really quietly. It's about the same as you would expect from like a white noise machine. You can see in the different operating modes, right? If it's pumping, if it's heating or cooling your space really actively, it's going to be a little louder, all the way down to 38 decibels, which is really, really quiet. Like I mentioned, it plugs into a 120 volt outlet, so it limits the need for electrical upgrades in the home, especially if you're thinking about like a large scale multifamily building. It's a highly efficient system, so it's really ideal for that type of installation. And then down on the right here, we'll talk a little bit about COPs and efficiencies. I know the other manufacturers mentioned those as well. We're 100% efficient down to 17 and then 80% efficient down to 5 degrees Fahrenheit. The lowest operating temperature that the system can operate at is -13. So obviously, you know, limited capacities down to that negative temperature. Let's see. Let's keep on going here. So a little bit of a demonstration. This is a very new emerging technology. Like I said in the beginning, we have been working with NYCHA and NYSERDA to do a demonstration in New York, in Queens, where we retrofitted a wing of an apartment building from steam radiator heat to gradient systems as the complete replacement, that completely displaced the existing system. So there's a little bit of background here. Local Law 97 essentially dictates that New York City housing has to be retrofitted to be electrified by 40, a couple different GHG targets here, but essentially the public housing agencies said they would do their best to electrify. And so that's kind of where we came in. They asked for us to commit to designing this cold climate system that would operate well as a cost-effective solution for New York to really electrify all of their public housing authorities. So here came the Clean Heat for All Challenge, where we met the RFP and won a contract for 10,000 heat pumps under the NYCHA contract. So, like I said, our initial deployment was in 2023, where we installed 36 systems across 12 different apartments. So that was 3 units per apartment. And there was a 10 times reduction in installation time compared to ductless mini splits. Each system took about an hour to install if you don't include removing the radiator and capping it off. So all in all, it was about 2 hours to install each system, and all of these systems were installed in just under a week. And so again, that's 36 units across 12 apartments. So getting into the performance of the systems, it's a highly efficient unit that speaks to the testament of a heat pump in general, but specifically speaking to the cold climate, this was a bit of a warmer winter for New York. So we reached down to like 19 or 20 degrees. But in this chart over here on the right, you'll see that the 3 gradient units that were installed in each apartment drew less power than 1 space heater at the coldest hour of the coldest day that was tracked in this study, with each unit drawing on average about 430 watts. So you can see down in this middle area, the more temperate the conditions are, the unit's going to operate much, much more efficiently. So around that 40 to 80 degree range, we're getting down to about 400 watts. One other portion of the RFP that was met for the Clean Heat for All Challenge through NYCHA was the how do we deal with condensate? Obviously, with traditional mini splits, you have to run refrigerant lines, you have to run condensate lines to make sure that to deal with the condensate. On our units, there are 3 nozzles that are on the external portions of the unit, as you can see in this bottom right-hand picture, that basically shows the condensate being atomized out into the air. So this removed the dripping that you might experience from a traditional window AC unit. If you've ever been dripped on in the middle of winter in New York, or I guess not in the middle of winter, but it's just not a very pleasant experience. So this dealt with our dripping issue. Let's see. And a little bit more on the preliminary results. I know we're running out of time here, Noah, so let me know when I'm cut off.
Yeah, no worries at all. I would say take your time here. I know we squeezed you.
Okay. So I think these are probably the most important couple slides here. So the preliminary results from the NYCHA study showed that we had a 85 to 88% reduction from steam heat to the heat pump. So this shows the 2 buildings that were retrofitted, or 2 portions of the buildings, they were really wings that were retrofitted from the steam heat to the gradient heat pumps. This represented about a 49 to 60% cost reduction in terms of the cost to heat the buildings, and a limited impact on the electrical load, really representing only 30% of the load at the heat pump's peak operation, which was really, really impressive. And honestly, I would say arguably one of the most important parts, how satisfied were people with using these systems? As people have mentioned before, heat pumps are new technology, and now we're introducing a new technology. And so this was a really important portion of the study to understand, kind of how tenants are interacting with the systems, if it kept them warm enough, right? And you can see overwhelmingly that they did. They were very, very satisfied with the new systems that were installed. They kept them very warm or too warm, just 4% too cold, which, we can work through that. They were very easy to use. So the interface, I can share more information if you're interested more about how we have the specific functionality of the interface, but essentially we have interface on the unit itself. And then we also comes with an app and as well as a remote. And then finally, the sound from the units was very quiet to okay, but nothing, no one thought that it was too noisy. So that was fantastic. Finally, just extrapolating these results to elsewhere, the units really has a lower upfront cost than other comparative systems that compared to a VRF installation or a mini split installation. The gradient system really is 30 to 54% cheaper of an install. And that really comes with the installation of the refrigerant lines or, not having to dig into the building envelope. And then finally, the lower operating cost compared to the higher efficiency systems. So there is comparatively to the baseline equipment that was replaced, you can see in each region kind of generally what kind of savings you would expect. I have a couple more slides, but I know we're really running out of time here. So I was going to go into the cooling efficiency and the heating efficiency. I'd be happy to answer other questions. But I guess I'll just close here and just say we're working with NEEP, with Energy Star, with CEE on this new technology just to produce the new product category. And we're very, very close to being fully Energy Star certified, which is fantastic. And again, I know other people have mentioned NEEP today. Similarly, we'll be soon to be posted on that list as well. And thank you guys so much. I really appreciate your time. And if you stuck around this long, really appreciate it. Please do email me if you have other questions.
Yeah, thank you so much, Sam. We certainly, we still have 121 people on the call. So clearly a ton of interest in this technology. Sam, really appreciate it. Awesome, awesome visuals. Huge kudos to whoever made that deck too. Crazy visual design skills. And awesome to see all the stats from real world testing. So yeah, thanks to all the panelists for staying late too. Really appreciate all your time, and everyone did a absolutely killer job. We'll be following up with a slide deck afterwards. So in case, you were here a little late, or for example, you wanted to see the gradient cold climate performance data too, you can take a closer look at all those slides, get more of that information. So with that, we will be having some more webinars like this of, different types later. We will send follow-up information on registering for those as well when they become available. But for now, thanks again for attending this. Yeah, you'll see a follow-up shortly. Huge shout out to our amazing panelists. Thank you all again.
Thanks, Noah.
Cheers, y'all, and have a great rest of your day.
Bye.